Okay, so now I want to look at actually calculating the cross product of two vectors. So let's say I have vector A equals 1, -2, -1. Vector B equals, and I'm purposely keeping the numbers small so we don't get lost with the numbers here, hopefully. Um, vector B equals 0, 4, -2. Okay? And we could graph these if we like, but for now let's just focus on the calculation of A cross B. And of course, you could think of vector A as being 1i minus 2j minus 1k, and B would be 0i plus 4j minus 2k. And we're sort of going to use these directional unit vectors I, j, and k to calculate the cross product with the determinant of a matrix. So the way to set this up is we're going to have a determinant of a 3 by 3 matrix, and the top row entries are the vectors I, j, and k. Then our second row is going to be A, vector A, 1, -2, -1, and our third row is going to be vector B, 0, 4, -2. So we have vector A as our second row and vector B as our third row. Notice there's no comma in the vector notation. But now if we get the determinant of this vector, we will get the cross product vector. Now, determinant of matrices is usually a number. This is actually going to result in a vector because 3 of our entries in this matrix are vectors, which is a bit unusual, but this is a way to calculate a cross product. So what we do is I've got my first entry, I. That's a positive entry, and I'll multiply that by something, minus the second entry, j, times something, plus the third entry, k. So I've alternated my signs. Now I just need to fill in what these are multiplied by. Well, when I look at crossing off the row and column with I, I'm left with the matrix that we have here. So I'll put that matrix over here next to I. Be really careful when you do this not to lose any of your negatives. Then next to j, if I cross the column off with j and the row off with j, I'm left with these 4 entries, which will create the matrix next to the j over here. So I've got 1, 0, -1, -2. Then we do the same thing with k. If I cross off the first column and the first row and the third column, I'm left with these entries, which give me the matrix I put next to k. So I have 1, -2, 0, 4. Okay, not too bad so far. So I've got our unit vector I times the determinant of this 2 by 2 matrix, which will be 4 minus -4, which is 4 plus 4, so that's 8, minus j times the determinant of this 2 by 2 matrix, which is -2 minus 0, so that's simply -2, plus unit vector k times the determinant of this 2 by 2 matrix, which is 4 minus 0, which is, of course, 4. So we have 8i plus 2j plus 4k. You could also think of that as being, in this component form, 8, 2, 4. So A cross B results in this vector. Okay, so I'll write that up here. A cross B equals 8, 2, 4. And now let's look at the picture of it to sort of verify that these satisfy the properties that we've looked at before. Okay, so now I'm going to draw all 3 vectors in 3 dimensions so we can sort of see that A cross B is perpendicular to the two vectors A and B, and it's oriented in the correct direction. So let's draw the x-axis, the y-axis, and the z-axis. So let's plot vector A. So I have an x of positive 1, a y of negative 2, and a z of negative 1. So vector A is right here. Coming forward, left, and down. Then let's look at vector B. So this is vector A. Let's look at vector B. It's x is 0. Then I go right 4, and I go down 2. So there's vector B. And now we have A cross B. Its x is 8, so 1, 2, 3, 4, 5, 6, 7, 8. Then I go right 2, 1, 2, and I go up 4, 1, 2, 3, 4. So here is vector A cross B. And the idea is vector A cross B is perpendicular to vector B, and it's a bit hard to see here, but it's also perpendicular to vector A. Maybe I can make this a little bigger so we can see it. So this angle right here between the blue vector and the yellow vector is also 90 degrees. Okay? Now, if you can imagine, the blue vector is pointing right at you, right? And then the other two vectors are sort of pointing downward. Okay? And the idea is if you imagine A cross B, you would rotate A towards B. So if you imagine that, if we rotate this direction, and we have a screw inserted right here where the vectors all meet, if I rotate that direction, I'm unscrewing the screw and it should point out, should point backwards towards us. Not this way, right? If I were screwing in, it would be going that way, but I'm screwing it out, so it's coming out towards us, and that all satisfies what we looked at before. Okay, so that's how to calculate a cross product vector, and we verified that it matches up with our idea of what a cross product vector is.